Hey everyone, good morning, good afternoon, good evening, depending on where you're at in the world. Thanks for joining us again today. My name is Chris Bennett. I'm a teacher with Blockchain Training Alliance, and we've been doing some really fun technology computer classes for kids this week. If you've been with us all week, then you know Monday we talked about blockchain and why that's such an incredible technology and why it's so important, especially right now. Yesterday, we talked about the Internet of Things and smart devices. And today, we're going to talk about something really fun. I've been looking forward to today all week. We're going to talk about programming, coding. So let's go ahead and dive in. We're going to talk about Programming 101. All the basic concepts and things you need to know to learn how to write your own code. So let's start off by talking about, well, why would you want to learn to program or to write computer code in the first place? Well, good reason is because the world around us right now is filled with computers. Everywhere you look, there's a computer inside of everything, whether that's your laptop at home or maybe the smartphone that you walk around with every day. You might have a smart watch. Computers are all over the place in new cars now, your video game console, your Xbox or your PlayStation. That's just a computer. So learning to program or write code, that's a great skill to have because you're learning the language of computers. And once you learn the language of computers, you know how to talk to them and how to make them talk to each other. So it's a really, really great skill to have. And it's an important skill to have because right now we don't have enough good programmers out there in the world. We have more jobs for programmers than we do programmers to fill them. So this is a really, really great skill, and it's a skill that's going to continue to be very important in the future as well. Not only is it an important skill and one that we really need, but it's also one that's a lot of fun. When you're able to speak that language of the computer and you can speak that language to make that computer do whatever you say, that's a pretty incredible feeling. It feels a lot like magic to be able to give these orders to a machine and have that machine just follow them exactly like it's supposed to. And it's a good skill to learn because it teaches you how to think about big problems in very, very small pieces. And sometimes the most overwhelming part of solving a big problem is just trying to understand all the pieces that go into it. So I hope what we talk about today gets you excited and you decide this is a skill that you want to learn. Maybe you've been wanting to learn programming for a while, but you haven't because you thought, you know what, it's just hard. It's too hard. You have to be really, really smart to know how to program. Well, that's actually not true. The thing about programming is people make it seem a lot harder than it really is. It's actually very, very easy. One of the reasons it's so easy to learn how to program is you already know all the basic concepts. Everything you need to know to write software, you already know right now, today. The only thing you have to learn is new ideas, new words, new ways of talking about these things you already know. And this is different from a lot of the things you have to learn because most things we have to learn, we not only have to learn new ideas, but then we have to learn new words to talk about those ideas. Programming is great because there's no new ideas to learn. The other great thing, that the reason programming can be so easy is because once you learn to program in one language, it's very, very easy to go learn another language. All the same ideas and concepts are going to be present in that other language. You may just have to learn some new words to talk about them. And so it's very common for a developer, a computer programmer, to work with many different languages all the time, not just one. So it's not as hard as you think. As I said, you already know all the basic concepts, and computer programming is nothing more than telling a computer exactly what you want it to do. A computer program is really just a list of instructions for a computer to follow when it needs to do a certain thing. And really, the hardest part about writing any program is figuring out exactly what you want that machine to do, what you want your computer to do. Because it means you have to give your computer all of the little steps involved. A computer doesn't know how to do anything unless you tell it exactly how to do it, step by step. And oftentimes, this is the hardest part about programming, is just breaking things down into small enough steps. So here's a great example. If I told any of you, hey, go wash your hands before dinner, before we eat. Well, you know exactly what that means. All I have to tell you is to wash your hands, and you know exactly what to go do. But I can't tell a computer to go wash its hands. A computer is not going to know what that means. If I want to tell a computer to wash its hands, I have to break it down step by step. So I have to tell that computer, hey, the first thing you need to do is go find a sink or a faucet. Then the second thing you need to do is turn on that faucet. And then you need to adjust the water temperature to the middle, halfway between hot and cold. And then you need to wait a few seconds so the hot water can warm up and start flowing out of the faucet. And then step number 5, stick your finger under the water and feel, is it too hot? Is it too cold? If it's too hot, you need to adjust the faucet to be slightly colder. And then you need to go back to step 5 and do it again and check to see, is it too hot or is it too cold? If it's too cold, you need to turn the temperature up a little bit. And then you need to go back to step 5 and do it again. And then finally, once you get the temperature of the water comfortable, well, then you need to rub your hands together under the water for a few seconds to get them nice and wet. Then you need to go put some soap on your hands. And once you've got soap on your hands, you have to rub your soapy hands together for a little while. And then you need to take your soapy hands and run them under the water to wash all the soap off. And then when you're done with all that, you need to turn off the faucet. And then you need to find a towel. And then you need to dry your hands on that towel. So this is the hardest part about computer programming, is taking something simple that we think of as being simple, like, hey, go wash your hands, and figuring out all of the exact steps it's going to take in order to do that simple thing. All right, now an important thing in computer programming is syntax and grammar, just like in our regular written language. In human language, when we're writing things down, syntax and grammar are very important. We use things like punctuation, periods, commas, exclamation points, question marks. We use those to help separate ideas and thoughts, so you know where one idea stops and another idea starts. And if you write some text and you have bad syntax and grammar, you have no syntax and grammar, it makes it much harder to read things, to understand things, to get meaning out of that writing or out of that text. And so just like in our written language, we have rules for syntax and grammar. In programming languages, we have rules for syntax and grammar too. But don't worry, because it's actually a lot easier than what you're used to. If you sit in English class or writing class, you know that the English language has a bunch of syntax and grammar rules, and they can be very, very complicated. Well, the syntax and grammar rules that we have in most programming languages are very, very easy, and so it's very easy to learn them. And there are a couple rules that we'll talk about that a lot of languages follow. But first, I'll give you a little example. If I showed you something like this, It would be very, very difficult to understand what the heck I'm talking about. You probably look at something like this and it just looks like a bunch of gibberish. It's very, very difficult to understand what was I trying to say? Where does one idea stop and another idea start? But if I show you something like this, now it's very easy for you to understand those things. You can see very clearly where one idea stops and another starts. You can read this and you can understand exactly what I was trying to say. Now, the interesting thing is, this is both the exact same text. All I've done is use a different syntax, different grammar rules for this first piece of text. With this second piece of text, I used the rules that we're all used to. And you can see how following those rules makes it a lot easier for the reader to understand. Well, your computer's the same way, and using the right syntax rules in your programming tells your computer how to read that computer code. So every programming language has its own rules and syntax, just like every language, every human language has its own rules. The grammar rules in Spanish are slightly different than they are in English. And the grammar rules in Mandarin Chinese are very different than they are in English. So different programming languages will have their own rules. But there are some rules that a lot of languages share in common. Not all of them, but a lot of them share in common. And so we'll talk about two big rules right away that you'll probably see all the time if you start writing computer code. And the first one is, how do we end a sentence or a statement? Well, if we're talking about the English language, we use a period to end a sentence, or sometimes a question mark or an exclamation point. But usually we use a period, and that tells us that one sentence or statement has ended and another one is going to follow. Well, we do the exact same thing when we write computer code, but in a lot of languages, we don't use a period, we use a semicolon. So a sentence or a statement in a lot of programming languages would end this way, with a semicolon at the end. That's the first rule. And again, this rule doesn't apply to all programming languages, but it applies to a lot of them, most of them. Here's another good rule that you'll see in a lot of languages. If you have a group of related things, they're enclosed, they're wrapped by these little curly braces. So for example, let's say I'm going to the grocery store later and I make myself a shopping list. And I say, well, I'm at the store, I need to get milk, and I need to get bread, and I need to get cheese, and I need to get some more carrots and potatoes. And I also need to get some more soap for the shower. So my shopping list is made up of these 6 items. And anytime I talk about my shopping list, I'm really just talking about these 6 things. Well, if I was going to write that in code, I might say my shopping list contains these 6 things. So I'm saying exactly the same thing as I'm saying on the left, but over on the right, I use these curly braces to say every one of these things inside of these braces is part of my shopping list. So there are 2 big rules you'll see all the time, and just knowing these 2 simple rules can make it a lot easier to look at some computer code and understand what's going on. All right. All programming languages have something called variables. And a variable is a pretty simple idea. A variable is just a name that we give to a piece of information. And that piece of information that we're giving a name to, we call it a value. So every variable has a value. And we use variables when we're programming so that we can store some pieces of information that we know we're going to want to work with later. Oftentimes in life, we know that there's going to be a piece of information that we want to work with, but we don't know exactly what that information is going to be. For example, let's say that your favorite sports team is playing a game, a big game tomorrow night, the championship game. Well, you don't know what the final score of that game is going to be. You don't know if your favorite team is going to win or if they're going to lose. But you do know that there will be a final score. Even though you don't know what that final score is, you know that there's going to be one. So you could think of the final score as being the variable, and then the value of that variable is whatever the score is, 53 to 8, 27 to 22. Here's another example. Let's say that you want to go write a computer program that's going to take temperature readings throughout the day. Every few minutes, it'll take a temperature reading. And then at the end of every day, it's going to report to you what was the high and the low temperature for that day. So if you think about a program like this, we don't know for any day what the high and low temperature is going to be. We don't know 2 weeks from Thursday what the high and low temperature is going to be. But we know that 2 weeks from Thursday, there will be a high temperature and there will be a low temperature. We just don't know exactly what they're going to be. Well, that's where we would create a variable. We could create a variable for the high temperature of the day and the low temperature of the day. And anytime we wanted to talk about that highest temperature, we would just use that variable. So here's a little example. All of us have an address. We all live somewhere. So let's say that I want to write a computer program that knows my address. Well, I might create a variable called my address. And then I tell my computer that the value of that variable is 123 Main Street. That's where I live right now. So then I can ask my computer, what is my address? What is the value of this my address variable? And my computer is going to respond, it's 123 Main Street. All right, well, let's say that then I move and I have a new address. So now I tell my computer that my address is now 987 Broadway. And now if I ask my computer, what is my address? What is the value of that my address variable? It's not going to say 123 Main Street. It's going to say 987 Broadway. But you'll see in both circumstances, I asked exactly the same question. I asked, what is my address? What is the value of this variable? And that value can change. It can change from 123 Main Street to 987 Broadway. But in either case, I'm always asking the same question. Anytime I want to talk about my address, I just use the my address variable. Here's another example of using a variable. We may see that we have a math problem like 2 plus 2. And whatever the answer to 2 plus 2 is, we want to store it in a variable named x. So if I add 2 to 2 and I save it as x, and then I ask my computer, what is x? The computer is going to tell me, well, x is 4 because 2 plus 2 is 4. All right, that makes pretty good sense. Now, what if I tell my computer to add x plus 2? Well, we already know that x is 4, so my computer is going to add 4 plus 2, and it's going to get an answer of 6. And I'm going to tell my computer, store that number in the x variable. So now if I ask my computer what is x, it's going to tell me x is 6. So variables can change their value, but that name is always going to be the same. All right, now let's talk about another important concept, routines. Routines can also be called functions or methods. Different languages may use a different word to talk about this feature, but they all pretty much mean the same thing, a routine, a function, a method. No matter what we call it, a routine is a list of instructions inside of a program. You can think of it as a miniature program inside of a program. And we use routines anytime we want to reuse the same code or the same set of instructions over and over and over again. We use a routine to just list out those instructions once, and then anytime we need to follow those instructions, instead of writing them out again, we just tell our computer to go execute that routine, go follow the instructions in that routine. And so these are very, very helpful things to use when you need to perform the same set of steps over and over and over again. So let's look at an example of a routine. Let's say this is what you do in the morning. The first thing you do is you wake up. And then once you wake up, you get out of bed. And then once you get out of bed, you go to the kitchen to eat breakfast. And when you get into the kitchen, parent is there, mom's there, dad's there. So you look at your parent and you smile and you say hello to them. And then you go ahead and you eat your breakfast. And then once you get done eating breakfast and getting ready for school, then it's time to get on the school bus to go to school. And when you get on the school bus, some of your friends have already been picked up. They're already on the bus. So you get on the bus and you see, hey, there's one of your friends. And so you're going to smile at that friend and you're going to say hello to them. And then a few rows back, there's another friend of yours, a second friend. So you're going to smile at that second friend and you're going to say hello to that second friend. All right, well, if you look at everything you're doing in the morning, notice that you're performing these same 3 steps over and over again. You're looking at someone, you're smiling, and then you're saying hello to them. In this little example, you did these same 3 steps 3 different times. You did it for a parent in the kitchen. You did it for a friend on the bus. You did it for another friend on the bus. So you're repeating these same instructions over and over and over again. And this is where we could create a routine. So let's say that we build a routine. And we're going to call this routine greet. And anytime you greet someone, you're going to perform these 3 steps. The first thing you do when you greet someone is you're going to look at the person that you're greeting. And then you're going to smile at them. And then you're going to say hello. So now if I want to do all of these exact same things, I can make it a lot simpler. I can say, hey, I'm going to wake up and then I'm going to get out of bed and then I'm going to go to the kitchen for breakfast and then I'm going to greet my parent. I'm going to greet mom or dad in the kitchen. And when it's time to greet that person, I'm going to follow all the instructions inside this routine. So when it's time to greet my parent, I'm going to look at them and then I'm going to smile and then I'm going to say hello. And then I can eat my breakfast and get on the bus. And then I see, hey, there's my first friend. And I want to greet that first friend. So when I do that, I'm going to go back to this greet routine and I'm going to follow all the instructions. I'm going to look at that first friend and I'm going to smile and I'm going to say hello. And then I'm going to do the same thing for my second friend. So it's a lot easier to look at this code than it is at this. Right? This is a lot more complicated. The other reason routines are pretty interesting, why they can be pretty useful, is imagine that you want to change your greeting. Let's say you don't want to say hello anymore. Let's say tomorrow you want to start saying good morning or good day or howdy or something other than hello. Well, if you don't use a routine, you're going to have to change what you say here and here and here. You're going to have to change that greeting in 3 different places. If I use a routine, I only have to change it in 1 place. Instead of saying hello, I could change this to good morning or good day or howdy or anything else that I want to say. So routines are an efficient way to keep reusing the same set of instructions over and over and over again. All right, now we'll talk about parameters, and parameters go with routines. A parameter is nothing more than some input data that you give to a routine. So let's think about if you're greeting someone. And if you're going to greet someone, you need to know who it is that you're greeting. So we may say that if we write a greet routine, like we looked at before, we might want to add a parameter to it called person to greet. And that means anytime we're going to greet someone, we also tell our computer who it is that we're greeting. And then we can make our instructions more specific. We want to look at that person and we want to smile at them and we want to say hello and then their name. So if our person to greet is named Tom, we're going to look at Tom because Tom is our person to greet. And we're going to smile and we're going to say, hello, Tom, because that is the name of the person we want to greet. So let's go back and let's look at your morning routine here, but let's add a parameter. So now I wake up and I get out of bed and I go to the kitchen and mom's in the kitchen. So I want to greet somebody. That's my routine. And the person that I want to greet is mom. That's my parameter. So when my computer gets to this step, it's going to say, all right, I need to greet someone and the person I need to greet is mom. So the first thing I'm going to do is I'm going to look at mom and then I'm going to smile and then I'm going to say, hello, mom. And then I'm going to eat my breakfast and then I'm going to get on the bus. And then I see my first friend, friend number 1. And friend number 1 is Deborah. So I'm going to go ahead and greet Deborah. I'm going to perform the same steps in this routine, but now my person to greet is different. So instead of looking at mom, I'm going to look at Deborah and I'm going to smile at Deborah. And instead of saying, hello, mom, I'm going to say, hello, Deborah. And then I see my second friend, Jamal. So now I'm going to do all these same steps again, but now my person to greet is Jamal. So I'm going to look at Jamal and smile and say, hey, Jamal. So those are routines and parameters. And again, these are very useful if you know you're going to need to perform the same steps over and over and over many different times in your program. Well, you can just write those instructions once, and then you can call those instructions as many times as you want without having to rewrite them. It's a great way to save time and to make it easier to read your code. All right, the next thing I want to talk about are statements. And the first one we're going to talk about is one called the if statement. And remember, your computer program is nothing but a list of instructions for your computer to follow. And sometimes there are instructions that you want your computer to follow no matter what. You should always perform this instruction. But other times there are instructions you want your computer to perform only if something is true. And if that thing isn't true, you don't want your computer to do it. And we work with this idea all the time in everyday life. So think about whether you should wear a jacket today or not. Well, the only time you wear a jacket is if it's cold. So you may wake up every day and you may ask yourself, is it cold? And if you say, yes, it's cold, then you know you need to wear a jacket. If it's not cold, then you don't need to bother with this instruction. You can just skip right over it. So in computer code, we would write that exact same statement this way. We would say, if it's cold, if it's true that it's cold, then I should wear a jacket. Otherwise, I won't. If it's not cold, I'm just going to skip this instruction. So that's an if statement, and we use if statements all the time to tell computers what to do, because very often we only want to perform one instruction or a set of instructions if something is true. We also have else statements, and else statements go along with if statements. In else tells us something to do otherwise. So let's continue our example. We know if it's cold. If I wake up and I ask myself, is it cold outside? Then I need to wear a jacket. Otherwise, if I ask myself, is it cold? And the answer is no. Otherwise, I just need to dress normally. Well, if I want to write this in computer code, the first part of this doesn't change, right? It's exactly what we had before. So I say, if it's cold, then I need to go ahead and wear a jacket. But else tells my computer, if I don't do this, do this. So if it's cold, I'm going to wear a jacket. Otherwise, or else, I'm just going to dress normally. So sometimes you just use an if statement. Sometimes you use an if with an else if there's an otherwise thing that should be done. All right, now we'll talk about switch statements. And switch statements are just a way of combining multiple if statements. So remember in our last example, we said we're going to ask ourselves, is it cold? And if it is, we're going to wear a jacket. Otherwise, we're just going to dress normally. Well, let's say we want to be more detailed than that. Let's say if it's really cold outside, I want to wear a jacket, gloves, and a hat. If it's just regular cold outside, but it's not super cold, well, then I just want to wear a jacket. I don't need to worry about wearing gloves or a hat. If it's a nice day outside, then I just want to dress normally. If it's hot outside, then I want to wear a t-shirt. And if it's super hot outside, it's an extremely hot day, then I might want to wear shorts and sandals so I can stay even cooler. So what I really have here is 5 different if statements. If it's really cold, if it's regular cold, if it's nice, if it's hot, and if it's extremely hot. And a switch statement gives us a much shorter way of combining all these multiple if statements together. So if I was just going to write all these out as if statements, I might have code like you see over here on the left. I might say, hey, if the current temperature is really cold, well, then I want my jacket, gloves, and a hat. If the current temperature is just regular cold, well, then I just want to wear a jacket. If the current temperature is nice, then I want to dress normally. If the current temperature is hot, then I want to wear a t-shirt. And if the current temperature is really hot, then I want to wear shorts and sandals. Well, I can say exactly the same thing with a switch statement. You see, all of these different if statements, all 5 of them, are looking at the same variable at current temperature and trying to determine what to do based on the current temperature. So I can write a switch statement and say, look at the current temperature. And if the case is that the temperature is really cold, well, then I want to wear a jacket, gloves, and a hat. If it's regular cold, then I just want to wear a jacket. If it's nice, then I just want to dress normally. So I can use a switch statement to say the exact same thing in a lot less code. I don't have to write all of these if statements together. And so this can just be a nice way to write shorter amounts of code and make that code a little bit easier to read. That's a switch statement. It's just multiple if statements put together. All right, now let's talk about a for statement. And a for statement is helpful. Sometimes you need to do the same thing multiple times. And so a for statement lets you repeat a piece of code or a set of instructions a fixed number of times. So you're going to put whatever you need to do, whatever those instructions are that should be repeated inside of your for statement. And that for statement is just going to repeat those instructions over and over and over until the counter hits a specific value. So let's look at a quick example. How do you do a push-up? Well, if you want to do a push-up, you start by bending your arms until your torso touches the ground. And then once your torso touches the ground, you're going to straighten your arms back out and raise your torso back off the ground. And then you're going to stop once you've straightened out your arms, once your arms are straight. And then if you want to do another push-up, you do the same thing over again. So if I was going to write out the instructions to do 3 push-ups, I could write them out like this. I could say, first bend your arms, and then straighten your arms, and then stop, and then bend them again, and then straighten them, and then stop, and then bend them a 3rd time, and straighten them, and stop. And you can see all I'm really doing with these instructions is repeating the same 3 steps 3 different times. Now imagine how long these instructions would be if I didn't want you to do 3 push-ups, but I wanted you to do 10 push-ups or 100 push-ups or 1,000 push-ups. These instructions would get to be really long, but you're only ever doing the same 3 things over and over and over again. So we can use a for statement to make it much easier to write that code. And this for statement may look a little bit weird at first, but that's okay. It's pretty easy to figure out. What we're going to do is we're going to repeat all the steps inside this for statement multiple times. So the first thing we're going to do is we're going to say this is push-up number, and then whatever number it is. This is push-up number 1. This is push-up number 2. This is push-up number 3. And then we're going to perform those 3 steps. We're going to bend our arms until our torso touches the ground. And then we're going to straighten our arms to raise ourselves back off the ground. Then we're going to stop when our arms are straight. Now, a for statement uses a counter. That's what's inside the parentheses here. What we're saying is we want to use a variable called x to be our counter. And we want to start off with x being 1. We want to do everything inside this for statement until x equals 3. So we're going to start with our counter at 1, and we're going to do everything. We're going to do push-ups until our counter equals 3. And this very last part here, x plus plus. This is just a shorthand way of saying every time we loop through these instructions again, add 1 to x. So let's step through this. Let's look at how this would work. We start off and we say, the very first time we do these instructions, X is going to equal 1. So the first time we execute these instructions, we're going to say this is push-up number X, and X equals 1. So we're going to say this is push-up number 1. And then we're going to bend our arms, straighten our arms, and we're going to stop. So now we've hit the end of our for statement. Can we stop? Do we need to do the for statement again? Yes, we do. Because we've said we aren't going to stop doing this until X equals 3. And right now, X equals 1. So we need to do this all over again. So we're going to go ahead and add 1 to X. And now X equals 2. So now we're going to say this is push-up number 2. And then we're going to bend our arms and straighten our arms. And then we're going to stop. And then we ask ourselves, okay, do we need to do this for statement again? Do we need to run these instructions again? Well, yes, we do, because remember, we can only stop once X equals 3. And right now, X equals 2. So let's go ahead and add 1 to X. And now X equals 3. So now we can say, this is push-up number 3. And then we bend our arms for a third time, and we straighten them for a third time, and we stop for a third time. And then the computer is going to ask itself, okay, can I stop now? Well, I can stop when X equals 3. And right now, X equals 3. So I don't have to do these steps anymore. I'm done. So right here, with just 5 or 6 lines of code, I can do all the same things that I was doing with 9 instructions before. And if I wanted to do 10 million push-ups, the only thing that would change would be this 3 right here. It wouldn't be 3, it would be 10 million. But think about how much longer these instructions would be if I had to do 10 million push-ups and I had to write all these 3 steps out over and over and over again. So these for statements can save us a lot of time repeating a lot of code over and over again. All right, our next statement, this is a very common one. This is called the for each statement. And this is a lot like a for statement, right? The for statement that we wanted to look at was great for repeating a set of instructions over and over. But for statements are good if you know how many times you want to repeat those instructions. Right? When we looked at doing push-ups, we knew we want to do exactly 3 push-ups. And so when we write that for statement, we want to tell it, hey, we only want to do these instructions 3 different times. Sometimes you know that you need to do the same things over and over again. You need to repeat the same instructions over and over again. But you don't know exactly how many times you're going to need to do that. So think about this. Let's say that you have a job at the movie theater, and your job at the movie theater is to work the popcorn line. So before the movie starts, customers come in and they buy their ticket, and then they go to the lobby and they get in line to buy a box of popcorn. And your job is to sell a box of popcorn to every customer in line. So it doesn't matter if there's 1 customer in line or 10 customers in line or 127 customers in line. No matter how many customers are in line, you're going to do the same steps for each of them. But you don't have any way of knowing how many customers are going to be in that line. Right? Maybe it's the middle of a day on Thursday, so everybody is at work or at school. They're not going to the movies, so you're not going to have many people in line. Or maybe it's a Saturday afternoon and the new summer blockbuster just opened up and the movie theater's packed, so you could have a ton of people in line. You don't know how many times you're going to need to perform these same steps, but you know that you need to perform the same steps for each customer that is waiting in line. And that's what a for each statement can be used for. So if you look at what are you going to have to do to sell a box of popcorn to each customer waiting in the line? Well, the first thing you're going to need to do is to greet that customer. And then after you greet that customer, you're going to have to go grab an empty popcorn box. You're going to have to go over to the popcorn machine and you're going to have to fill up that empty popcorn box. Then you're going to have to give that popcorn box to the customer. And then you're going to have to take the customer's payment. Right? You take their money and give them change, or you swipe their credit card. You take their payment for that popcorn. So we know that for each customer, we're going to have to do these 5 things. We're going to have to perform these 5 instructions. But we don't know how many customers there are going to be. So we don't know how many times we might have to write out these 5 instructions over and over. In a for statement, it wouldn't work because we wouldn't know when the counter should stop. We don't know how many customers there are going to be. So the for each statement is used here. And if we were going to code this out, we could say for each customer that is in the popcorn line, we want to do these things. We want to greet the customer. We want to grab an empty popcorn box. We want to fill that box. We want to give the filled box to the customer, and then we want to take the customer's payment. And if there are only 3 customers in line, then we're only going to repeat these steps 3 times. If there are 20 customers in line, we'll repeat these steps 20 times. We're going to repeat these steps once for each customer that is waiting in the line. That's what the for each statement is all about. All right, and then the last statement type that we'll talk about is the while statement. While statements are kind of like for each statements. They allow us to repeat a set of instructions or a set of steps over and over again. And just like a for each statement, we don't know how many times we're going to need to perform these steps. It may be once, it may be 10 times, it may be 100 times. We don't know. The only thing we know is that we need to perform these steps while something is true. So let's say that you work at a restaurant. Well, what do you need to do if you work at a restaurant? While that restaurant is open, you need to perform these steps. While your restaurant is open, you need to greet your customers when they come in. And then you need to seat those customers at a table. And then you need to give those customers a menu. And then you need to come back in a few minutes and you need to take that customer's order. Then you need to prepare that customer's food. You have to go into the kitchen and cook it. And then once that food is ready, you have to bring it out to the customer so they can eat it. And then when the customer is done, you need to take their payment. Now, you need to do these 7 things over and over and over again while your restaurant is open. But once your restaurant is closed, you can stop doing all these things. And you might ask yourself, well, isn't this exactly like a for each statement? Couldn't I just say for each customer that wants to eat at my restaurant, do these 7 things? Well, you could. They're very similar. But here's the difference. If you use a while statement, you're only going to perform these steps while something is true. Let's say that your restaurant can only serve 100 people a day in the hours that it's open. And let's say that there are 150 people who want to eat at your restaurant today. Well, what that means is you can only serve the first 100. If you wrote a for each statement, that for each would say, all right, go do these 7 steps for each customer that wants to eat, all 150 of them. But my restaurant's only open long enough to do these for the first 100. So I can use a while statement, and then I'm only going to perform these steps while my restaurant is open. Now, again, you don't know how many customers you're going to have on any given day. So you don't know how many times you're going to have to perform these steps. And it's not just as simple as saying, hey, perform these steps from 6 a.m. to 8 p.m. every day, because your restaurant might be open different hours on different days. You might have different hours on the weekends than you do on weekdays. You might have different hours on holidays than you do on regular days. So the only thing you really know is that you need to perform these steps anytime your restaurant is open. So you could write this as a while statement. And you could tell your computer, while the restaurant is open, go ahead and do these 7 things. So I'm going to start off my day. Is my restaurant open? Yes, I just opened it. All right, let me go greet that first customer and seat them and give them a menu and take their order, cook their food, bring it to them and take their payment. All right, is my restaurant still open? Yes, it is. All right, let me go greet that second customer and seat them and give them a menu and take their order. All right, is my restaurant still open? Yeah, okay, then let me go do all this with the third customer. All right, now I get to the end of my day and it's 8 o'clock, it's closing time. So I turn off the sign out front. And now my restaurant isn't open. So even if there are customers still waiting, I'm not going to do any of these things anymore because my restaurant is no longer open. All right, well, those are just some of the basics. Variables, routines, if statements, for each statements, while statements. If you understand these basics, and you already should, because again, these are ideas that you already work with every day. We're just learning how to express them a little bit differently. We're just learning to write them as something like this instead of something like this. And everything that we've talked about, these variables, routines, if statements, for statements, these exist in any programming language that you want to learn. So if you want to learn C++, or you want to learn JavaScript, or you want to learn Fortran, or you want to learn C#, well, any of those languages is going to have an if statement. And those if statements are going to work exactly the same way as we talked about today. They may just be written a little bit different from one language to another. But everything we've talked about today are the basic building blocks of programming. And if what we talked about today makes sense, then you're ready to pick a language and hit the ground and get started and actually start learning and building. And there are many different computer languages out there. There are hundreds, perhaps thousands of different languages. And so sometimes it can be a little tough if you know that you want to learn more about programming. One of the toughest questions to answer after that is to figure out, well, what language should I start with? Is there one that's better than another? Is there one that's easier than another? Well, the first thing to remember is there's no best language. There's not one that's better than any other. Some people have very strong opinions and they like one more than any others. But different languages are better at doing different things than other languages. So it's good to explore and to find one that you like and that works with the type of things you want to work with. But if you're looking at just getting started, I would recommend that you start with one of the 4 languages on this slide. JavaScript, Microsoft's Visual Basic.net, Microsoft's C#.net, or Python. And I'll talk about each of these. JavaScript, is a good option to start with, because JavaScript right now is the world's most popular programming language. It's the most heavily used language there is right now. And so that means if you want to learn JavaScript, because it's the world's most popular language, there's a lot of information out there. You're going to find a lot of books and tutorials and online guides and YouTube videos and Reddit forums. It's really, really easy to learn JavaScript because it's so popular. So that can make it a really good place to start, because there's so much good information out there. Another reason you may want to start with JavaScript is that JavaScript is the language of the internet. JavaScript is the language that many different websites are built in and coded in. So if you want to get started in web development and building things on the internet, JavaScript can be a really, really great language to learn first. Another one is Microsoft's Visual Basic.net, or you'll sometimes hear this called VB.net. This is a great one to start with because it has the easiest syntax of any programming language out there. Visual Basic Code is the closest to plain English writing as any programming language gets. So if you understand all of the ideas and the concepts that we talked about here today, but things like the semicolon or those curly braces are confusing, they're weird for you to look at, well, then you might want to look at Visual Basic. It doesn't have any of that. And it has a very, very easy to read syntax. Another good language you might want to start with is Microsoft's C# or C#.net. This is kind of a fun one because this is a very, very common language for doing video game development, for writing games or for creating extensions or add-on for games. So if you're interested in writing your own game, or maybe you have a game that you love playing and that game supports custom extensions, custom add-ons, and you have a cool idea for an add-on that you want to build and share with the rest of the gaming community. Well, there's a good chance that you're going to need to learn C# in order to do that. So that might be a great language to learn if you're into gaming. And C# has a very, very similar syntax to JavaScript. It's almost identical. So if you learn JavaScript, it's very easy to go learn C# afterwards. Or if you learn C# first, it's very easy to go learn JavaScript afterwards. And then the fourth one you might want to consider starting with is Python. And Python is a language that is used very, very commonly if you want to interface with or interact with external devices. So if you were with us yesterday, you remember we talked about IoT, smart devices, and the Internet of Things. Well, if you want to start writing software to control a device, something in the physical world, there's a very good chance that you're going to need to write that code in Python. So if you're interested in IoT or robotics or building drones or remote control vehicles, you might want to start with Python. And there's some really, really great resources that you can use if you want to learn more about coding and you actually want to get hands-on. There are two really good ones that I'll point out. The first is W3 Schools. And you can visit them just by going to w3schools.com. And W3 Schools has tutorials on 3 of the 4 languages we talked about. You can learn JavaScript, Python, or C# there. They don't have any Visual Basic tutorials, but they have some really good ones for these other languages. Everything you do at W3 Schools, you do in the browser. So you don't have to worry about installing or configuring anything, getting anything set up. As long as you can access a browser you can go through the lessons on W3 Schools. So you can do it from a laptop, a tablet. You can do it from your smartphone if you want. And all of the lessons are just short, bite-sized lessons. Most of them take 10 minutes or less. So you can just sit down and go through a couple lessons, and then when you're ready for a break, you can go do something else. You're not sitting down and going through hours and hours worth of work. And the thing I like most about W3 Schools is it's hands-on. You learn by doing. So for example, here's their site. I could say, hey, I want to learn JavaScript. Chris said that was a pretty good language. And you'll see a lot of the things we talked about, right? Like the switch statement. I can come in here and I can learn all about how a switch statement works. And then when I'm ready, I can go ahead and try it myself. So I get my code over here on the left, and I can hit run, and I get my answers on the right. So here's some code to tell me what day it is. Well, let's say that I wanted to say Wednesday in all uppercase. I can change my code here, and then when I run it, I'm going to get a different result over here. So I can play with my code right here in the browser, not have to install or set anything up. So great resource there, W3 Schools. The other real good resource I would encourage you to look at is code.org. This is a great free online site to help kids and people in school learn coding and computer science. So they've got some really, really good resources here. You can go to code.org and click on this Learn tab. And you can get signed up to take free lessons. You can learn coding and all sorts of other great topics, exciting topics in computer science. And then, of course, if you're interested in learning more and you want us to put a class together, let us know. We would love to put together a more detailed class and work with you guys to get hands-on and start writing some of your own code. So thank you, everyone. I appreciate you making some time and joining us today. And if you've been with us all week, thanks for joining us Monday, yesterday, and today. Hopefully this has got you excited about coding and computer programming and you want to learn some more. It's a great skill. And like I said, we need more good programmers out there. So hopefully someday I will see you guys out there in the world writing some amazing computer code. So thanks again for joining us, and be sure to stay safe, stay healthy, everyone. And if you want to learn more, go ahead and dive into these sites and get hands-on because it really is easier than you think.